All right, in the first part of our 7B review, the instructions tell us that the following expressions represent the area of a rectangle, and we are asked to rewrite the expression so that it reveals the dimensions of the rectangle in terms of x. So remember, dimensions are things like, in this case, length and width. So really, we are trying to rewrite our area expression in factored form. And so when I say in terms of x, I mean there will be x's in our length and our width. So for this very first example, if we draw our area model, we know that our quadratic term, so our x squared term, that's always going to go here. And our constant term, which is positive, 18, is going to go down here. So as I fill this out, I'm going to write x squared and 18. And so we are looking for two numbers that have a product of 18, and really we could think of it as 18x squared. However, those two numbers have to have a sum of -9. So for two numbers to have a positive product and a negative sum, they have to both be negative. So two negatives multiplied equals a positive number. All right, so if we think of all of our factors of 18, I'm going to make them all negative. So we have -1 and -18. We have -2 and -9 and -3 and -6. So if we ask ourselves which of those has a sum of -9, that's our -3 and -6. So we know -3x and -6x have to go in these two boxes. It doesn't matter which goes in what spot, but we want to double check that they do indeed multiply to positive 18x squared and that they have a sum of -9. So now the last thing we have to do is pull out our GCF. So if I look at this column, the greatest common factor of x squared and -6x is just x. And I know that if I put an x there, I have to have an x here so that x times x is x squared. So again, if I'm looking at this column, if I factored out an x at the top, I would need a -6 down here so that when I multiply those two things, I get my -6x. And then I know I also pulled out an x from this row on the left. So I need a -3 up here so that -3 times x makes my -3x. And then I could just double check -3 times -6 is positive 18. So our final answer is that this area could be expressed as x minus 3 times x minus 6. So again, when I'm getting my answer here, that's the dimensions that I've labeled on the side. So like the length and the width of the rectangle. All right, number 2 might seem tricky because there's no constant term, but we could think of that as a +0. And like if you wanted to, you could still use the 4 section rectangle for the area model. But now we're looking for numbers that multiply to x squared and have a sum of, that multiply to 0x squared. So numbers that multiply to 0. So I know that one of those numbers has to be 0. And then they have to have a sum of 5. Well, 0 times any number is going to give us a product of 0, but I would have to have 0 and 5 to get the sum of 5. So I could put my 5x here and 0x down here if I wanted to. So now when I go to factor, my row at the top, I could pull out an x. I know I need an x here. And then I could think of this rectangle as being x plus 5. I could write a +0 down here. When we answer this in factored form, we could just leave it x times x plus 5, but that is the same as like if I wrote x plus 0 or -0 times x plus 5. Those would both be correct. We don't really need the +0, but we can put it there if we need it. All right, for number 3, the good news is we have all positive numbers. The bad news is that 48 has a lot of factors. So again, I've got a positive x squared. So this box is positive, a positive 48. And then I need two numbers that multiply to positive 48 and have a positive sum. So I know all of my numbers here are positive. So I've got my x squared, my 48, and I just have to think about factors of 48. So we've got 1 and 48. We've got 2 and 24. We've got 3 and 16. We have 4 and 12, and lastly 6 and 8. And if you need or want to use a calculator to help finding those factors, that's just fine. But when we think which of those has a sum of 14, that's going to be our 6 and our 8. So we know we have 6x and 8x in our boxes. So again, if we double check diagonally, our product is 48x squared. Diagonally this way, our product is 48x squared. So that always has to be the case. So now when we pull out our GCF, if I pull out an x here, whoops, because x is the greatest common factor of x squared and 6x, that means I also have to have an x up here. And then to make this positive 6, I would need a plus 6. Going down this column, we already factored out an x out top, so I would need a plus 8 here. So our final answer is that we could express the area as x plus 6 times x plus 8. All right, and then lastly, in number 4, I would encourage you to try these on your own and then check them, but if you still need help with number 4, all right, so we've got our x squared term, and we know that's going to be positive, but our constant term is a negative number, negative 70. So that means that to multiply two numbers to get a negative, one of those numbers has to be negative and the other one has to be positive. And it doesn't matter where you put the negative or where you put the positive, it just helps me to think about it. So I'm have my x squared here and my negative 70 down here. And so we're looking for two numbers that have a product of negative 70 or negative 70x squared and a sum of positive 3. So if I need them to add to a positive number, the greater of the two numbers has to be the positive number. So when I think about my factors of negative 70, well, let's see, I know I've got negative 1 and 70, but that's really far apart, right? Because that would have a sum of negative 69. I have negative 2 and positive 35. 70 is not divisible by 3 or by 4. 70 is divisible by 5, so we have like negative 5 and 14. All right, we're getting closer. Let's see, and then we've got negative 7 and 10. Oh, now wait a minute. I think those numbers work because their sum is positive 3. So I'm going to put my negative 7x here just because I color-coded that one red to be negative. It doesn't matter though. You could switch where I have the 10x and the negative 7x. You could swap those diagonally. So again, we want to double check, yes, our product is negative 70x squared. Those two numbers add up to this positive 3 that we need. So we get, so now we can factor. So if I pull out my GCF of this row, I can pull out an x because that is the greatest common factor of x squared and negative 7x. And that means I also need an x here, so that x times x is x squared. I need a negative 7 here, so that this x out on the left and negative 7 make our negative 7x. And then I need a plus 10 down here. And I should double check that 10 and negative 7 do multiply to negative 70. So again, our area could be written as x minus 7 times x plus 10. And you can always swap the order as long as the 7's negative and the 10 is positive.